Welcome to Auto U. This is a update for the people at NASA who are interested in how the potential difference generator operates and where we're at. Briefly, to review Lenz's law, when a magnet approaches a coil of wire and current flows in the coil of the wire, the coil produces a magnetic field which is the same as the approaching magnet. When the magnet starts to move away, the current changes direction, therefore the field in the coil changes and attempts to pull back the magnet. Now, in the potential difference high voltage coil, high impedance coil, the scenario is pretty much the exact opposite. When a magnet moves towards a coil of high impedance, the impedance of the coil causes the current in the coil to be very minimal. And if the current is small enough, there's no repelling field. So there's very little effect on the approaching magnet. When the magnet is no longer approaching nor is receding from the coil has in it a very high stored voltage. And the voltage is stored between the wires in the electrostatic field. When the magnet is not moving away, the frequency is zero. The impedance of the coil is just the DC resistance of the coil, and the voltage that's stored in the coil is dissipated through the DC resistance of the coil and produces a magnetic field and pushes away the magnet on the rotor. Now, it pushes away the magnet on the rotor, but it also attracts the next magnet, the South Pole magnet that is approaching. Now, what we have done here is we've taken a high voltage coil and a high current coil, and we put them together. We have a high voltage coil wound in the center, and around it we have a high current coil. Here's an example of the high voltage coil with the high current cores, and here we have the high voltage winding in the middle. Here's another example with high current windings on there, and here's another example with this one. I'm using a laminated core. The previous two that I just showed you are using AC MIG welding cores. Now, what we have in the concentric bicoil is when the magnets are approaching the concentric bicoil, the high current coil has the conventional effect. It produces a magnetic field. The high voltage coil does not produce a magnetic field, and it has very little effect on the approaching magnets while the magnets are approaching. However, when the magnets stop, and I should point out that stopping means when the magnets are top dead center. When the magnets on the rotor or the magnetic field is neither approaching nor receding, at that point the frequency is zero, and the high voltage coil discharges its voltage, its stored voltage, through the DC resistance of the coil, and it pushes away on the now receding magnet. Now, not only does it push away on the receding magnet, but it attracts the next magnet that is approaching the, the three separate coils. And what I'm going to be doing in part 2 of this is I'm going to be demonstrating this, this new coil here, and I'm going to be showing specifically three things. I'm going to be showing conventional generator operation where the high current coil causes deceleration, the high voltage coil acceleration, and then the high voltage coil acceleration while the high current coil is loaded. So stay tuned.